Okay, so what we're looking at today, first is what we call taxonomy. So taxonomy, the definition for this is it's the science of naming things and assigning them to groups. So with this, basically what we're doing is we're looking at all the different life on Earth, different life forms. It could be bacteria all the way to the most complex. So now say like an elephant, or you can see in here, you only got bacteria in the corner. You have mushrooms, plants, frogs, rabbits, rams, cows, birds, amoebas, parasites. So what we want to do is we want to try and classify these so we can kind of put them into an organization, and we can kind of basically compare them and have an easier way of identifying what they are. So looking at taxonomy, the reason we're doing this, again, we want to have a single universal name for an organism. So that's what we use is kind of a scientific naming for that. But a lot of times there's time, and we'll see here in a moment, there's times when we have one organism that has multiple names. Let me mark this down so I don't forget Marcolia. So having a single universal name will help avoid confusion. So a lot of times when we look at it, we may say a name for an organism, well, we go to a different part of the country or a different area, and that name means something else. And the other thing that does is kind of we've been looking at here is looking at how organisms are related to each other. So we can actually see, and this is where we can start building those phylogenetic trees, and we can start kind of looking at common ancestors and looking at how organisms may have evolved over time. So we talk about kind of one of the issues here, like, talking about like avoiding confusion, is here we have one of the big cats, and here we have this cat actually has 5 different common names. And a common name is something that we just kind of call things based off what we know. And so what's one of them, Dayton?
Google, mountain lion, and mouse.
So a cougar and mountain lion are 2 of them. And anybody online or anybody else in the classroom would like to share what they would call this?
Panther.
Yeah, panther's another one. There's 3 of the 5. The other 2 are a little bit trickier. Let's see, anybody online? Okay, and so your second. Okay. So there's 3 of them. One of them is kind of more of a rare name, depending on where you're located. We hit kind of the 3 main ones. So we're looking at this, and it kind of depends on the location that you're in. So I think is that one of the ones I had? Okay. So kind of depending on looking at them. So one of the names for us where we live, this is most commonly called a mountain lion. Okay. So that's kind of like what we would refer to it as. It can also be referred to as a cougar, puma, the panther, and that's known primarily in Florida. And also we do have the catamount. And the catamount is kind of in the Appalachian Mountains and kind of more in like the Virginia, West Virginia area. Okay. But again, we're looking at just a single organism here that has 5 different names. So depending on where you are, so say if I go down to Florida and start talking about mountain lion, they may not know what I'm talking about. Or when people are, say, somebody from Florida comes here and they start talking about panthers, right, we may be thinking of something completely different. So common names are good, and they can kind of help us begin to identify things. They're normally not specific enough. And so when you look at like the taxonomy, so it can be confusing if we don't have a scientific name. So looking at the organism we have here, and it says, doesn't matter where you go in the country, it's the same species. And so we're looking at this, the scientific name would be Felis concolor. So we can have a bunch of different common names, but like for us, the mountain lion, the proper name is Felis concolor. And so we include the genus and species, which we'll talk about each of those here in just a moment. Okay. So looking at how we name them, so this is what we call the binomial nomenclature. So it does go a little bit more in that, but whenever we use the scientific name, where the binomial refers to basically 2 names. All right, so like here we have the Felis concolor, which is the 2 names. So it's the binomial nomenclature there. So this was developed by Carolus Linnaeus back in the 1750s, so it's been around for a very, very long time. But we do always include 2 parts of this. We always include the genus and species when we talk about the scientific name of an organism. And then also a key thing here is when we do use scientific names, they need to be either italicized or use italics or underlined. And so a lot of times when we do this on a computer, we'll use italics. If we do it by hand, we underline it because it's hard to write in italics by hand. So whenever we do this by hand, we normally will underline it to indicate that it is a scientific name. Whenever we do it on a computer, we almost always use italics. And then we also use Latin terminology for this. It is a dead language and it's only really used by scholars anymore. And the reason why we do this is because most languages, different languages have, different terminologies. Even within the same language, we might start calling things or using words over. And so we use Latin, so it's basically there's no miscommunication about what it is. So here's an example looking at humans. So for humans, what our scientific name, we are Homo sapiens. So if we actually look this out, what these mean in Latin, it just simply means wise man. So it's a scientific name for humans. So Homo is the genus, so that refers to wise, and sapiens is the species, which is our proper species. And so kind of looking at the, sorry. They might have the other one later on. So this is just kind of looking at what humans are if we were looking at like our scientific name. So our common name would be humans. Our scientific name is Homo sapiens. Almost forgot to take that out. So then the taxonomy. So one of the key things is identifying what a species is, and we did talk about this on Friday a little bit, especially this very first part. And so one of the key things in order for something to be considered the same species, kind of like we talked about last week, is that they need to be able to breed successfully, and most importantly, they need to have fertile offspring. So remember Friday we talked about the horse and donkey being able to mate together, but their offspring, which is the mule, cannot produce offspring. So the horse and donkeys are two different species. It's just that they can mate together, but their offspring are sterile or they are infertile. Some other things that we use for this as well is we look at their features. They need to have unique features that are similar to each other or, of the same species. Okay. And we're looking at features. Features a lot of times aren't the greatest example for this. And one of the examples that we've kind of looked at or I've used in the past is looking at like a shark and dolphin. So if you look at a shark and dolphin, they have some very, very similar features. So if you look at them, they live in the oceans, they have similar body structure, they have fins, they have their kind of flippers on the side, they have a dorsal fin, they also have a tail fin. But they also have features that are completely different. So like the sharks, for example, are, they are fish, whereas the dolphins are mammals. So sharks have gills where dolphins have lungs. Sharks, their tail fin is vertical, so it goes up and down. The dolphin's tail fin is horizontal, which is flat. So their features can be used, they can be good, but they can also be kind of misleading. And then now what we're starting to use more and more is actually DNA. So the organisms of the same species, their DNA will be almost identical to each other. So looking at like humans, for example, when we compare one human to another, our DNA is 99.9% identical. That 0.1% though is actually a pretty significant difference. So it's going to give us kind of those traits that are unique. But the reality is our bodies are basically almost identical to each other, except for those few little key differences that make us basically diverse. And just looking at this, I think we talked about the bonobo on Friday, which is another species of primate, and that we shared 94% of our DNA with. So that 6% though is a significant difference. So looking at the kind of the overall taxonomy, and you guys may have seen this in the past or at some point, basically what we're looking at here is how we group things. So as we start at the top, the kingdom is the biggest grouping. And we'll look at a couple examples here in a little bit. And then as we go down, it gets more and more specific, where species is just an individual species, so it's only one species. See, the kingdom is all species that are animals, or all species that are plants. So we just go down, we kind of break them down by certain characteristics and certain traits that we'll look at the end of this lesson. So like I said, the kingdom is the most specific, it's kind of the largest group. And the species then is the most specific, contains only one type of organism or only one species. So here's kind of an example looking at humans as well as a plant. So for like the kingdom, we are part of the Animalia kingdom. So we're in the same kingdom as, say, you know, cats and dogs. We're in the same kingdom as sharks, same kingdom as elephants. Basically, any animal is part of that animalia kingdom. Then as we go down to, you know, the phylum, we're in the phylum Chordata. All right, that just means that we have a spine or we have a backbone. All right, so for us, our spinal cord means that we are a part of the Chordata family or phylum. All right, so and we'll be with anything else that has a spine. All right, our class then is we're mammals, so we'd be part of the Mammalia class, all right, which means that basically we have hair and we have mammary glands. All right, mammary glands are basically they produce milk for offspring. All right, so that's something unique to all mammals. And you can continue looking, you know, we're part of the primates order, our hominidae family, then our genus is Homo and species is Sapiens. So our scientific name would be Homo sapiens. And then our common name is we're humans. So that's kind of what we are. Look at another example here with plants. So the kingdom for plants would be Plantae. The phylum again basis for plants is on how they reproduce. So like in this case, the sunflower, they use what we call the angiosperm, and so their phylum is Angiospermophyta. And then on the class, I'm not, can be honest, I'm not exactly sure the class order and family here. But then looking at the actual species, this is what we call a Ranunculus acris, which is the buttercup sunflower. And so there's other types of sunflowers out there. So their genus would still be Ranunculus, but their species would be a different name. This is looking at the actual buttercups or the specific buttercup type of sunflower. But again, kind of the key thing is recognizing that, you know, the kingdom is the biggest group. So, you know, for the plants, this would basically have any plant that we know of on Earth. So we could talk about, like, say, an oak tree. We could talk about different types of grass. We can even go into look at, like, see, you know, aquatic plants such as, you know, like seaweed. And so these would all be parts of that Plantae family that they get broken down into different groups, right, based off certain characteristics. So in general, we're looking at taxonomy. Based off what we know now that DNA has gotten to the point where we can use it consistently and accurately, right, we now classify things using DNA. Right, so it's much more precise. We're able to determine exactly what it is based off its DNA. We can use morphology. Morphology, again, is like the study of what organisms appear like. So that, like, morphology is what do they look like. So we can use this, but the issue pops up, like we talked about, let's say sharks and dolphins. They have some very, very similar traits, but they also have very unique traits. Another example here is looking at, like, say, the arm structure of organisms. So if we look here, we have a human, cat, whale, and bat. Well, if we look at these, you know, if we look at their upper arm, or, you know, and like say the wings of a bat or the flipper of a whale, but we all have the same bone structure. So the humans, we have a humerus, cats have a humerus, the whale has a humerus, and a bat has a humerus as well. So all four of these species, you know, all four of them, you know, look very different. They have the same bone structure in their arm. We need to look in their forearm. We have the radius and the ulna for humans. Cats have a radius and ulna. Whales have a radius and ulna too. It's obviously it's a little different shape, but they're the same bones. Right? Bats have the exact same as well. We can get into the carpals and the wrists, and you can see kind of light yellow. All four species will have the same. If you count, they actually have the same number as well. Then we have our metacarpals and our phalanges, which are the same among all of these. So you notice there are some slight differences, such as the whale has a lot more of what we consider like the finger bones or the phalanges. But other than that, they have basically the exact same structure. So it's kind of morphology is where it can be misleading, but it can also kind of point us in the right direction. Another system we're going to be looking at is what we call a cladogram. Cladograms kind of show the same thing, but they also show the branching or, you know, what the differences are. So if we kind of start back here, and as we go like kind of down this or down the very bottom to see earliest in time. And so when we get to our first branch, when you can see here, we have the hagfish. And so the hagfish, in this case, you can see the hagfish does not have jaws. They basically just kind of have their open mouth with some crazy teeth that are, you know, kind of freaky to look at. But anything past the point where we see that the jaws means that all the organisms past that will have jaws. So like a perch, salamander, lizard, pigeon, mouse, and chimp, all those organisms have jaws where the hagfish does not. The next branch point that you can see are lungs. Anything past that point, so like the chimp, mouse, pigeons, lizard, and salamander have lungs. The perch does not. The perch has gills. So it's just kind of showing that each of those points, what that key characteristic is that distinguishes them from the rest. We also notice here the feathers are in a slightly different location. So this indicates that the pigeons are the only organism that has feathers. Whereas like they say the mouse and chimp, all right, mouses and chimp, they have fur or mammary glands, they have claws, nails, they have lungs, and they have jaws. So you're gonna see going back, they have everything below that, all right, but nothing above. So like in this case, the lizard or the salamander does not have claws or nails. They kind of have like their feet are more pads. So like I said, this is kind of a real quick look through of taxonomy, kind of looking at how we actually classify organisms. And so let me pause this for a second.